Okay, Assalamualaikum warahmatullahi wabarakatuh. Today is I want to explain about the independent data and dependent data. So, there are 4 questions here. So I will go through for the exercise 1. Okay, this is they have a group and BMI here. Okay, they have a step to analyze the normality data. Okay, for to get the normality data, which is the value of normality data, if the p value is more than 0.05, it is considered as normal. Okay, so first step we do is we go to analyze, and then this statistic we go to the explore. Okay, then we got here we got dependent list and factor list. So dependent list we should put BMI, and then the group put as a factor list. Okay, then don't forget to plot tick the descriptive, which is histogram, and then untick the statement diff, then tick a normality plot with a test. So continue. So if okay, we will get the result. So we got here the test of normality. So we got here so the BMI of the athletes and non-athlete. Okay, the athletes, the significant we get here is 0.092, and compared to the p-value, which is 0.05, so the result is normal because the significant is higher than 0.05. So this is non-athlete also, we get 0.601, it's higher than 0.05. So the test of normality, we get the result is normal. Okay, next we need to compare. So we go to the analyze, and then we go to compare means. Get here compare means. Okay, get here compare means, and then we go to the independent sample t-test. Okay, so you must insert the test variable here. Test variable is BMI, and for the group we put a group here, and then make sure you don't forget to define the group, because to separate each. So the group 1 we consider as 1, group 2 consider as 2, and then we continue. So after continue, we can get the result. Okay, so the result here we get. Okay, so the first is 0.7. So we should look the BMI of the variance assumed here. So the result is we get 0.756, which is the p-value is more than 0.05. Okay, then we look to the two-tail. So the two-tail is we get the p-value is 0.000. So the p-value is 0.000, so it's less than 0.05. So the result is that is significant difference. So the result is not normal here. Okay, next we proceed to the question number 2, which is also independent data. So we get here is group and total energy expenditure. Okay, we also need to first go to get a normality data. So we analyze, and then go to descriptive, and proceed to the explore. Okay, first total energy expenditure will shoot list independent list, and then for the group we put in the factor list. So make sure don't forget to plot, also same as the question 1. So tick histogram and then tick normality plot with the test. So continue. So the result will get here, the result will get okay. So the result, okay, the total energy expenditure, so we get the lean and obese here. So first lean 0.048, meaning that is less than 0.05, and so the result for the first is not normal. Okay, the obese is 0.143, so the normality is normal. Okay, so if we get the result like this, we should do analyze. Okay, so the next step we proceed to the, because there's different data, go to analyze, and then we go to the non-parametric test. Then we go to the legacy dialogues, and then we choose the two independent sample here. Okay, in this independent sample test, same as the previous, we should first is total energy expenditure, we put in a test variable, and the group we put in here, but you should define the group first. So the group is first group, group 1 is first, group 2 is 2. So continue. After continue, we should choose the test type, which is the Mann Whitney U. Why we choose this? Because the data is not normal, because the less than 0.05. Okay, then we click OK here, so we get the result. So here the result here is we look at the two tail here, 0.02, meaning that the peak value is 0.02, so P is 0.02 is less than 0.05, so there is significant difference about the result. Okay, next I will proceed to the exercises of 3, which is exercise 3 is dependent data. So the dependent data, first we need to transform first the difference. So first we choose transform, and we should put compute. Okay, so compute variable is here, target variable we should put DIF, which is short form by difference. So the numeric here is we put post menstrual first, this, and then we minus then this. So post, we put minus here, and post menstrual. So after that, after this we'll click OK, the result will appear here. Okay, next step we need to analyze the normality. So we go to the analyze, and then we go to descriptive statistic, and then we go to the explore, same as previous. Okay, so here we only put this to the dependent list. Okay, then don't forget to plot also histogram, and click the stem and leaf, and then normality plot with the test. Continue. So that we click OK. So the result here we get the normality test is 0.490, meaning that the normality is normal, because the p p-value is more than 0.05, which is 0.490. Okay, after that we want to compare the mean, so we go to the analyze here, analyze, and then compare mean, and then we put a pair sample t-test here. Okay, this have a pair variable, variable 1 and variable 2 here. So the variable 1 we put the pre-menstrual, which, and then the variable 2 is post-menstrual. Okay, after we put here, we click OK, and then we can see the result. Okay, so the result we see that a significant total here, which is 0.000, meaning that the p-value is 0.00. So p-value is less than 0.05, and that is a significant difference. Okay, next we proceed to the next exercise, which is last exercise, exercise 4, also a dependent data. Same, we need to analyze first the difference. So what should do is transform first. Okay, compute variable. Okay, target variable is we put same DFF, then same as here is minus post BMI, post, insert, minus, and pre. Okay, after this we click OK, and then we get the difference here, -3, -3, -5. Okay, after that we want to analyze the normality, so we go to analyze, and then we go to descriptive, and we go to explore. Same as the with the previous question, which is we only they put this difference independently, and then don't forget to plot histogram and normality to get the data. Okay, after that click OK. So we get the test of normality is 0.061 here. So meaning that is the result is normal because the is more than 0.05. Okay, after that the third step is we to compare the mean. So we analyze, and then compare mean and pair sample here. Okay, same, the first one is we put a pre-BMI here, the variable 1, and post BMI to variable 2, and then we click OK. So here we get the pair sample test result, which is the significant total, which is 0.00. So the p-value here is 0.00, meaning that is p-value less than 0.05, and that is significant difference. So that's all. Thank you.